want to use. And so we can write the following. We can say that tan, and just cover up what we want, right? So we want the adjacent. So that tells me that the adjacent is opposite divided by tan, right? So I can actually just jump ahead and sort of straight away write that down. So we can say that, we'll write it like this. So the opposite, which is 2.2, divided by tan of the angle of interest, which is 18, that gives me my adjacent. So this just goes into my calculator, right? So 2.2 divided by tan 18, that gives me 6.77. Okay, so that means that this length here is 6.77, which means that, and that's dA, right? So we can put 6.77 in here. And so we can use this answer to then use Pythagoras theorem to work out what dB is. Okay, so then we're going to write 6.77 squared plus 6 squared. I'm going to square root all of this. And that's going to be equal to dB. Okay, so this goes into our calculator. So answer squared plus 6 squared, right? And then we square our answer. That gives me 9.05, right? We're going to carry our answer through anyway. And then finally, I can add this sort of onto the diagram, the next diagram. So this is 9.05. And now finally, I can use right angle trigonometry again, but I want to find an angle this time. Again, the two sides that I have are the opposite and the adjacent. And, the way to think about how trig works, of course, is, trig functions, what they do is they take an angle and give you a ratio. So if you put that ratio into an inverse trig function, that gives you the corresponding angle. So what I want is the following. I know that x is going to be equal to the inverse tan of the ratio of interest for tan, which is the opposite divided by the adjacent. So that's 2.2 over 9.05, and therefore x is going to be equal to, so again we'll save our answer in here, so tan inverse of 2.2 over our answer, and that gives us 13.7, correct to 1 decimal place.